There is a viral story circulating right now claiming that half of all artificial intelligence data centers have been canceled. It sounds like a disaster for the industry. It sounds like the boom is over. But the reality is far more complex and actually reveals a deeper shift in how we build intelligence. The truth is that the demand for artificial intelligence is not slowing down. In fact, it is accelerating beyond anything we have seen before. Global electricity consumption for data centers is projected to more than double from 415 terawatt-hours in 2024 to nearly 1 terawatt-hour by the end of the decade. This surge is driven primarily by large language models and heavy training workloads. So why the cancellations? The bottleneck has shifted from hardware procurement to energy infrastructure. We are hitting a wall of grid capacity. Here is the thing. The primary driver for canceling nearly half of planned United States artificial intelligence data centers is a critical shortage of grid power capacity rather than a lack of demand or technology. Concentrated siting of artificial intelligence facilities is creating severe regional power system stress. This is forcing delays that extend well into 2026. In areas like Oregon, Virginia, and Ireland, grid stability faces significant challenges. The market corrections are already visible as capital-intensive projects face immediate cancellation due to the inability to secure reliable electricity connections. This trend suggests a future where artificial intelligence growth becomes geographically constrained to regions with robust power grids or where on-site generation and storage become mandatory prerequisites for deployment. The bottleneck has shifted from hardware procurement to energy infrastructure. This indicates that future artificial intelligence scaling will be dictated by the speed of grid upgrades and energy storage solutions. Now consider this. If you cannot build new massive facilities, how do you keep the intelligence flowing? The answer lies in a strategic architecture shift. We are moving away from the assumption that more cloud capacity is always the solution. Instead, the focus is on optimizing existing clusters for machine learning workloads by consolidating models and adopting edge inference to survive reduced cloud capacity. This is not just a technical tweak. It is a fundamental change in where computation happens. For years, the strategy was simple. Send all the data to the cloud. Train the massive models in central hubs. Run the inference from those same hubs. But with power becoming the limiting factor, that model is becoming unsustainable. Imagine a highway system where the main interstate is completely clogged. You cannot just build more lanes forever. You have to reroute traffic, optimize the flow, and perhaps let cars handle some of the driving locally. That is exactly what is happening with artificial intelligence infrastructure. We are seeing a move toward consolidating models. Rather than running dozens of specialized small models scattered across different regions, companies are beginning to merge capabilities into fewer, more efficient large language models. This reduces the total number of active inference requests that need to travel across the network. It concentrates the load where power is most reliable. It allows for better utilization of the expensive hardware that is already installed. Every watt counts when you are fighting for grid access. Then there is the shift toward edge inference. This means processing data closer to where it is generated rather than sending it all the way to a central data center. Think of it like a local warehouse versus a central distribution hub. If you need a specific part to fix a machine, you do not ship it from the other side of the country. You get it from the local depot. In the world of artificial intelligence, this means your smart device, your factory sensor, or your local server handles the immediate decision-making. Only the complex training or the massive updates go back to the central cloud. This drastically reduces the bandwidth and power requirements for real-time operations. It also makes the system more resilient. If the main grid fluctuates, the local edge node can continue to function independently. This approach is becoming a prerequisite for deployment in regions where the power grid is unstable. We are seeing early adopters in industrial settings implement this architecture to bypass the volatility of the public utility network. They are installing their own generators and battery storage systems to ensure their artificial intelligence applications never stop. This creates a decentralized model of intelligence that is less dependent on the fragile state of the national grid. This evolution creates a new geography for artificial intelligence. The future of the industry will not be defined solely by who has the most chips. It will be defined by who has the most reliable energy. We are looking at a landscape where artificial intelligence growth becomes geographically constrained. Regions without robust power grids will see their expansion stall. Capital-intensive projects face immediate cancellation due to the inability to secure reliable electricity connections. This forces a re-evaluation of location strategy. Companies are now looking at regions where grid stability is guaranteed or where on-site generation and storage become mandatory prerequisites for deployment. The bottleneck has shifted from hardware procurement to energy infrastructure. This indicates that future artificial intelligence scaling will be dictated by the speed of grid upgrades and energy storage solutions. It is a race not just to build the best models, but to build the most efficient energy systems around them. The companies that win this race will be the ones that treat energy as a core component of their software architecture, not just a utility bill. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.